So this is day 5 of quick revision mechanics class, right? So today it is one of the most important lesson, work and energy, right? Work and energy. So right, take this down. Work and energy. Under that, right? First, I will be talking about work, right? You just have to take down what I'm writing on the board, right? Right. So work is what? Whenever you say work, to have a work, you need a force and a displacement. So force times displacement is the work. In simple terms, force times displacement, right? Another thing is work is a scalar. Work is a scalar. It is not a vector. Work only has a magnitude. Work only has a magnitude. So it is a scalar, right? So we measure work in joules, right? Joules. So it only has a quantity, right? It only has a magnitude, meaning it only has a quantity. We don't have to think about a direction when we're dealing with work, right? Okay. So when the force is constant, right? The applied force is constant. Applied force is constant. We can simply use this one. Let's say you have an object and under force F, it moves from here to here. That object moves from here to here under a constant force. Then you can apply this. W equals Fs. Okay. W equals Fs. So this is one of the forms that you would get questions. Actually, this is force and the displacement should be to the same direction, right? Let's say if you apply the force like this, and this angle is theta, displacement is s. You apply a constant force, but the object is moving to this direction. You always have to consider the component towards the displacement, right? Force component towards the displacement. So what is the force component here? That is F cos theta, right? You cannot consider this one. You always have to consider force component towards the displacement. So in that case, the force work equation changes like this. F cos theta times S, meaning Fs, I can write cos theta here. So this is the another form, right? Take these two forms. This is one form of the questions. This is another form of the questions. Quickly take them two and thumbs up, right? Once you take it down. Right. So the another form, right? You can write it down if you want. Another form, the object is moving to this side. Object is moving from here to here, but the force applied is to the opposite direction. So a force like this always causes the energy to lose in a system. Energy drops because of a force like this. These are resistive forces, right? Like friction, air resistance. So work done by a force like this, we say negative force, because it decreases the energy in the system, right? So we say this is minus Fs. So this is the work done by a resistive force. Actually, it is a negative force. Sorry, a negative work. Negative meaning it decreases the energy of the system. That's why we use a negative there. Take it down as well. So all these for F constant, right? Okay, so that is for F constant. So that is one type of the questions, right? You will get another type if F varies, force varies. At the last class as well, we saw whenever the force varies, you have to get the area of a graph. Remember that was a FT graph, but for this case, it is a Fs graph. So in that case, work is equals Fs graph, area of Fs graph. Okay, we'll see when we do questions. If force varies, you have to consider area of the Fs graph in order to find work, right? You cannot use equations in that case. You have to use a graph there. Okay, take it down. Okay, right. Take the tute then. Try the first question. Try the first question and send me the answer. Send me the answer in the chat box, right? Try the first question. So everything will be clear once we do the questions, right? Okay, try the first question and send me the answer in the chat box. Okay, we'll see, right? We'll see. So what do they say? 50 kilogram of mass is held at a 2-meter height. So you are holding the mass, right? You are just holding the mass. You are not, they are not saying that you are lifting up the mass. You are just holding the mass. So what should be the force that you have to apply? You have to apply 500 Newton of force upwards. What's the displacement? Displacement is not 2 meters, right? You are just holding that one. There's no movement of the force. You are just holding it. So displacement is 0 in that case. So what is the work? 5000 times 0. So the work is 0 there, right? You are not doing any work. So the answer should be fifth one, right? That's why I gave you that question. Understood, right? Answer is fifth one. You are just holding it. You are not moving the force. For another example is, let's say, I'm pushing this board, right? I'm pushing this board, but the board is not moving. The board is not moving. Actually, the work we are doing is 0 in that case, right? In order to do a work, the force needs to have a displacement. Without that, there's no work. Got it? Without that, there's no work. Right. Turn to get the essay questions. Essay questions are at the back. Get to the essay questions. Try fifth question, right? Fifth essay question. And send me the answer. That's a simple question, right? Send me the answer. You have to understand the theory through questions, right? Yeah. For that one, you apply a force 12 Newton and the distance is 5 meters. So you just have to apply the force equation. 12 times 5, so it is 60 joules, right? 60 joules, yeah. So it is the 60 joules, yeah. Answer is given. Okay. Then try a 6th question, essay question, right? 6th essay question. If you did that, thumbs up, right? That also is an easy question, right? So first, in the first question, they ask what's the tension. So if you have 5 kilogram and the weight is 50 Newton, right? So you need a tension also should be 50 in order to hold this like this, 50. Okay, tension is 50 and the work done by the tension is 0, right? Because there's no movement. Tension is not moving, right? With the object. Right. Then try second MCQ. Second MCQ in the tute. It doesn't matter you get the wrong answer, right? Just use the chat box. So your answers are the only thing that I can understand whether I have to further clarify or not, right? So use the chat box, okay? Okay. Second one. So you know what a Cartesian plane is, right? YEX plane, XY, that this is called a Cartesian plane. Point 03, what is that? So these are XY coordinates. 03 means X is 0, Y is 3. So x is 0, y is 3, somewhere here. This is the coordinate 0, 3. Okay. Then another coordinate is 4, 0. X is 4, y is 0. Y is 0, x is 4. Got it? So what do they say? You are moving object to this direction. And the force applied is 5 Newton. By applying a force 5 Newton, you are moving from here to here. Object. So what they ask is work. So what is the work? Force is 5 Newton to that direction of the displacement, right? So what is the displacement here? This height is 3, this length is 4. 3, 4 means if you apply Pythagoras theorem, 3 squared, 4 squared, root of that. So this side is 5 meters, right? 5 meters. So the force is 5, distance also is 5. So we have to do a 25 joule of work. Isn't there an answer? The answer should be 25 joules. Is there a third answer? The answer should be 25 joules, right? Just make it a 25 joules. I think there's a mistake with this one. The force may be like 6 Newton or something like that. Right. So you just have to multiply those two, right? Right. So always you have to find no, area of the triangle we cannot get, right? We cannot get the area of the triangle. This is a y, both sides, those are displacements, right? Y is displacement, x also is displacement. So the area of the triangle doesn't give us, this is not a VT graph. Displacement is for a VT graph, right? Area. Okay. These only shows the positions, right? Right. So all you have to do, force, multiply the displacement by the force towards that displacement. That's all. Always you have to do. Right. Then try a third question. Third question. So the force is given, displacement is not given, right? You have to find the displacement. What would you do to find the displacement? Obviously, you are going to need motion equations and F equals ma, those stuff, right? Okay, first thing, in order to, you know force, but you need to know displacement. In order to find displacement, we need to know acceleration first. So to find acceleration, just apply F equals ma to this direction. So the force is 2, mass is 5, acceleration. So the acceleration is 205. 2 divided by 5 is 2.5 meters per square second, right? So that is the acceleration. Then we need to find distance, s. How do we find that? S equals half at squared. Initial velocity is 0. So ut 0. Half, acceleration is 2.5. Time is 10 squared. So that is 100. So this is 250 divided by 2. So that should be 125 meters, right? 250 divided by 2. So it should be 125. So what is the work now? So the force is 2 Newton. Displacement we found as 125. 2 times 125, 250 joules. Got it? So you should be able to do, all the time those equations should be in your mind, right? So you can quickly use them and get the answer. If you are clear, thumbs up, right? Taking it down. 250 joules is the answer, right? There's a problem with that. I think there's a printing mistake there. Yeah, 250 joules is the answer, right? The previous ones have copied to the downwards. Acceleration should be sorry. Yeah, acceleration should be 205. So it is 2 divided by 5 is 0.4, right? 2 divided by 5, 0.20 divided by 4, that is 4, 0.4, yeah, true. Then you have to apply it here, 0.4. 0.4 times 100 is 40, right? Yeah, 20. Then multiply force by 20. Yeah, sorry about that. So it is 40 joules, right? 40 joules. Fourth one is the answer, right? Got it? Right. Take it down. Then try a fourth question. Fourth question, right? Try the fourth question. So you just have to find, so you are given a graph. You just have to find the area of the graph. That is going to be work. Okay. Area of the graph. So when you have a FS graph, it gives us the area, gives us the work. So it's a trapezium, 2, 6, 8. So area is what? 8 plus 4. This is 4. Sum of parallel sides divided by 2 multiplied by distance between those parallel lines. So the distance is 10, right? 12 times 5, that is 60 joules. Third one, yeah, correct. Third answer. Okay, try the next one. So that also is a graph. Taking it down, right? So there's some difference in that, right? You have negative displacement. Carefully listen to this, right? So let's say you have the origin. Origin means this is where the displacement is 0. Initially the object is at here, like, so -2 means object is behind the origin 2 meters. So object is here. But the forces are positive forces, right? So all the time forces are applied to this direction. Forces are applied to this direction. Even after when it passes origin, forces are applied to this direction. Displacement, it is moving to this direction. All the time forces are to this direction, and it is moving to this direction. It is moving from -2 to +6. -2 position to +6 position, passing origin. So here what you have to understand is, all the time force and the displacement is to the same side. So both are positive work. This is positive, this also is positive. That you have to understand, right? Meaning you just have to take the whole area as the work. You just have to find the area of the trapezium. Understood? Area of the trapezium. Okay, this is not a negative area, this is a positive area. So send me the answer. Just find the area of the trapezium, right? So this from here to here 6, here to here 2, so this is 8. This one 2 plus 2 divided by 2 times height is 4. 2, 10 times, so it is 20 joules. Got it? If you taken it down, thumbs up, right? So this is the work, right? Then we'll try 6th question. For the previous one we got right. Okay, for this question we'll see, this is positive work, this also is positive work, force is positive, displacement also is positive. But what about this negative force? Due to the negative force, the object is moving to this side, right? But while it is moving, force has inverted. So while it is inverted, it is doing a negative work. So this is a negative work. Okay, so what's the area here? 10 times 2, 20. Here the area is 4 times 10. This length is 4, right? 6 minus 2. 4 times 10, that is 40 joule, but it is a negative. Then this is 2 times 10. This is 20 joules. So just have to add all these. 20 minus 40 plus 20. Actually, the net work done by is 0 there. Do we have answer? Yeah. First one is the answer. You cannot add all this. Right? This is a negative work. Got it right? Negative work, that is. So now you have to clearly understand what I mean, right? Force needs to be inverted. Displacement being negative does not mean work is going to be negative. Right. Okay. So that is mainly about work, right? Those are the variations of work. So somehow you just have to take force times displacement. The force should be always parallel or to the same side as a displacement. If it is not parallel, you have to take the component of that force towards that displacement. That's what you have to do in order to find the work. Let's say the work is to the opposite, if force is to the opposite direction, then the work done by is going to be negative, meaning the system is losing its energy. So that is caused by a resistive force. So those are the main variations of work, right? First, you have to understand that. Right. Then I'll be moving on to energy. Write the topic energy. Subtopic energy. Right. Write this down. Ability to do work. Ability to do work is the energy. Ability to do work is the energy. Okay. Ability to do work is energy. Right. Right. So in this lesson, we are mainly talking about 3 types of energies, right? One is kinetic energy, other one is gravitational potential energy, that is MGH. Another one is elastic potential energy, related to springs, right? Springs like that. So that is elastic potential energy. So all these are categorized under mechanical energy, right? So in this lesson, we are only talking about mechanical energy. Other types of energies like heat, heat, current, electric energy and light energy. Those types of energy are considered to be energy losses in this part, right? Here we are talking about mechanical energy types, right? When we say energy in this unit, right? Okay. Under that, right, ME energy types. ME mechanical energy, right? Mechanical energy types. Right. First type of energy, kinetic energy. You can take this down as I'm writing, kinetic energy. So what's the equation? You know the equation, right? Half mass V squared. That is a kinetic energy. There's nothing more to it, right? Just the equation. Then we have gravitational potential energy. So for that, first take it down. So for now listen, right? Gravitational potential energy. First thing, you have to define potential energy zero line. So that is like a reference line, right? Reference level. So if you lift an object above that reference level, that is PE zero line, if you lift that, we consider that to be a positive energy, positive potential energy. If we lower the object below that line, we consider that a negative energy, right? Negative potential energy. So whenever you get a question, you have to mark P equals zero line. when you have to deal with potential energy, gravitational potential energy. So below this it is minus mgh, right? Above it it is plus mgh. Take it down. If you didn't understand, send me, right? Above it is plus mgh, below it minus mgh. Taking it down, thumbs up, right? So those are the mainly two things. The other one is elastic potential energy, right? Many students are not familiar with this, right? Other one, take it down, elastic potential energy, right? Elastic potential energy, right? So elastic potential energy, what is the elastic potential energy? So when you apply a force on an object, let's say a spring, right? So you have like a spring there. This could be any object, right? Like a rod or a string. Let's say a spring. So you have this spring here. Let's say you can compress, so pull this one, right? So if you compress that to a x amount by applying a force, capital F, right? So we have to do work against the spring. The work we did is stored in the spring as potential energy. Understood? So this is the equation, right? F equals kx. K is the spring constant. Remember? K is the spring constant, or we call force constant. For a spring, K is going to be spring constant. So if you can notice, as it compresses, when x increases, force also is increasing. So here it is not a constant force, right? It is an increasing force. If you need further compressions, you need to further increase force. Okay. So what happens when a force is a varying force? You have to go for a graph in order to find the energy. So as you can see, F is y, this x is x, k is m. So you have a y equals mx graph. So this is the variation, right, of a y equals mx graph, which goes to the 0 and a linear. So the area of this graph is going to be the elastic potential energy, because work we did to do the compression is stored as potential energy in the spring. So, okay, so how do we find this work? I'll say potential energy, right? This work is stored as potential energy. Then this is equal to half this value f, this value x. This is the area of a triangle, half f x, right? So this is the one of the equations to find potential energy. Then you can substitute, right? Then you can substitute F equals kx here. F equals kx here. So for the potential energy, what do you get? Half. Instead of F, you can use kx. Kx times x. So what do you get as the potential energy? Half kx squared. So this is the another equation to find the potential energy. Kx squared. So you need to remember both the equations. Okay. Take everything down and thumbs up, right, if you take it down. Okay. So those are the main energy types, right? Then write the topic energy conservation law. Energy conservation law. Under that, right, energy neither can be destroyed. Energy neither can be destroyed nor created. Energy neither can be destroyed nor created. Energy neither can be created nor destroyed. So you know that, right? That's what we meant by energy is conserved. So if you consider a closed system, the energy cannot be destroyed, or meaning it cannot disappear, right? So what can happen to the energy? Energy can be turned into different types of energy, right? Meaning kinetic energy can be turned into potential energy, or kinetic energy can be turned into thermal energy, right? Or kinetic, I mean, when we think about electrons or those particles, due to vibrations, due to kinetic energy of those, energy converts into light, right? So always energy only can be converted into a different types of energy, but it cannot disappear, right? Or no can be created, right? But in this lesson we are talking about mechanical energy conservation, right? Under that, right, ME conservation, mechanical energy conservation. So under mechanical energy conservation, what we have is kinetic energy plus potential energy. This is a system. Sorry, this is constant for a system, for a closed system actually. In a closed system, kinetic energy plus potential energy is constant. Take it down. Then write, if it is not constant, ME is not conserved. ME is not conserved, causing an energy loss. Causing an energy loss. Right? So energy loss means it converted into like thermal energy, right? It converted to light energy, electric energy. So we consider that to be energy loss, right? When we are doing questions, right? Let's take the tute. First, we'll try some of the essay questions. First, try the second essay question. We'll start from simple questions, right? Second essay question. If you got the answer, thumbs up, right? So what does it do? A pump lifts 5 kg of water to a 10-meter height, meaning its potential energy increased by mgh. Then it gives that water 4 meters per second velocity, meaning it is given a kinetic energy. So the total work, I mean the increase of energy is increased due to the pump, due to both. So potential energy plus kinetic energy. Understood, right? Then just substitute values and tell me the if you get the answer, thumbs up, right? M 10, H 10. Got the answer? And if you have any issue, please tell me, right? 540 joules. Okay. So in the question, they say a pump lifts 5 kg of water, right? Let's say this is 5 kg. 5 kg of water is lifted to a 10 meter. Right? 5 kg of water is lifted to a 10 meter. Then that water is given a velocity 4 meters per second. So what they ask is, what is the energy increase of that water? So it is lifted up first, then it is ejected at 4 meters per second. So mgh is increase of potential energy. Half mv squared is when it is given a velocity. Got it? So then you just have to substitute those values. So this is the increase of energy in the system. Understood or not? Understood, right? Okay, take it down. Then try third question. Essay, right? Essay, third question. You can draw a sketch, right? If it is like too confusing, you have to understand the theory through questions, right? That's the purpose of doing questions, to understand the theory, right? The more you do questions, more you understand the theory. First draw this sketch. If you got the answer, send me, right? Did you find the spring constant? So how do you find the spring constant? Check under the note, right? I gave you. What's the equation? F equals kx. F equals kx. Remember? This force is not a constant force. With x, when x increases, force also increases. Right? So what is the force applied on the string? When you have a 20 Newton load applied, force applied on the string is 20. That is going to be the tension, right? Tension. So due to that force, the string extends by 1 centimeter. So if you want k in terms of meters, you have to convert centimeters into meters. So 1 centimeter means 0.01 meters. Or in other words, 1 over 100. You have to divide by 100 in order to make it a meter. Then put this to the other side, cross multiply. So k is equal to 2000. 2000, so the unit is newtons per meter, not per centimeter, right? We convert it into meters. So this is the spring constant. Spring constant. Got it? Then you have to find energy stored. Energy stored, right? So what's the equation to find energy stored? Half kx squared. Half kx squared. Okay, now just do the substitution. 2000 x is, so I have to convert here into meters, right? So 1 over 100 is square of that. 1000 divided by 100 squared means 10,000, right? So 3 zeros cancels off, 3 zeros cancels off, 1 over 10 is 0.1. So the energy stored is 0.1 joule. If you got it, thumbs up, right? Do you have to explain again? No, right? Right. Then try seventh question. So with the seventh question, we are moving to the energy conversions, right? Try seventh question. If you want, you can draw a sketch. You have a spring and you have a bullet moving 2 meters per second. Its mass 16 kilogram. So when it hits the spring, it starts to compress. Starts compressing, right? Let's say it compressed by simple x amount. Now the bullet is stuck here, right? Do you understand the energy conversion here? I'll tell you, I'll explain again if you don't understand, right? So what happens here is, just listen to this. So bullet has a kinetic energy. Since it has a velocity, it has a kinetic energy. That kinetic energy, what happens when the bullet goes and is stuck here, totally the bullet stops At that moment, bullets had completely stopped, right? Meaning that kinetic energy is totally converted into something else. Now the bullet doesn't have a kinetic energy, right? So bullet had a kinetic energy, but it has completely converted into something else. That total kinetic energy is converted to compress this spring. So when a spring compresses, that total kinetic energy stores as potential energy of the spring. Understood, right? So you should be able to write those equations. So half mv squared is the kinetic energy. This kinetic energy converted into the potential energy of the spring. Now the system doesn't have any kinetic energy. So that whole energy is as potential energy of the spring. So this is half kx squared. Now you can get rid of half. Then just do a substitution. That's all you have to do. If you understood, right? Then do the substitution. 16, velocity is 2 squared, k is 100, x is squared. So what they ask is compression. Take the root of the whole equation, right? Square root of the whole equation. 16 root means 4, 2 squared root means 2, 100 root means 10, x squared root means x. I just put like this, right, to both sides. So 8 divided by 10. So it is 0.8 meters. 0.8 meters is the compression. Take it down, and if it is everything clear, thumbs up, right? Somehow you must understand these concepts, right? Not understanding these concepts is why the physics seems hard, right? So you have to these are the basic concepts, okay? Right. Then try 9th question. 9th. Draw a sketch first, right? Draw a sketch. Try 9th question. I'll give you a minute. Right? Actually, there are two ways you can do this question, right? There are two ways you can do the question. One way, I'll just explain both ways, right? First type. For the first type, you have to consider P equals 0 line. This method is more complex, right? Complex means you can apply this for any type of question. Any type of energy question, you can apply this method. But it is better to use when the question is complicated, right? Let's say the question has like 2 or 3 energy types. Then you have to follow this. What I'm going to explain. If it is simple, if it is a simple one conversion of energy, then you can consider the second question type. So I'll explain first type that is applicable for any energy type, right? So at the first case, we consider this is the first state. Then this is the second state, right? So at the first case, according to energy conversion, what should happen? Energy at this case is equal to energy at this case. Total energy here is equal to, I'll say total energy, is equal to total energy at the second case, right? Okay, so this is the P equals 0 line. If you want, you can consider P equals 0 to here as well. You can choose any level, right? But I chose this level, right? So what is the total energy here? This is at rest initially. So the kinetic energy is 0 at first case. Potential energy, it is above P equals 0 line. How much above? So we know that this length is simple L. This length is simple L. Then this length should be what? L cos theta. L cos theta. This length is L, adjacent side cos theta. Okay. Then this total length is L. So what should this be? L minus L cos theta. I think you understood that one, right? Total string is simple L. This length is L cos theta. Then subtract L minus L cos theta is this length. So that's the height here from P equals 0 line to state 1. So mg, what's the height? L minus L cos theta. This is t equal 1. Then t equals 0. Sorry, TE2. I'll write it here. This side is t equals 1 side, other side is t equals 2. State 1 energy equals state 2 energy. So when the object reaches here, it has a velocity, right? Let's say the velocity is v. I think that's what you need to find. Yeah, this velocity. So what's the kinetic energy? Half mv squared is the kinetic energy. What's the potential energy at this level? Potential energy is 0 because it is at P equals 0 line. Okay, now you just have to simplify this. G, you can take L from each. 1 minus cos theta equals half v squared. I got rid of simple m, right? Then cross multiply 2gl 1 minus cos theta equals v squared. Take the root. 2gl 1 minus cos theta. Root of that. So that's the velocity. If I need to explain that again, tell me, right? Otherwise take it down and thumbs up. So this is the first type, right? Okay. So you have to, you will have to do this again, right? At a later date. These questions you have to try on your own. Okay. Okay. Then try. There's second type, right? Second type. So the second type is what is recommended. But if the question is complicated, you have to use this method, right? This is complicated. If you have more than 2 types of energy, you can apply this method. But if you have only one conversion, right? You can think about that. It is easy to think about that. This is how you do it. When the object is here, it has potential energy only. As it reaches here, potential energy of the object becomes 0. So that potential energy has to convert into something, right? So what's the potential energy here? Loss of potential energy, we can say decrease, let's say decrease of potential energy. As it reaches here, potential energy decreased, right? That potential energy converted into kinetic energy. So you can consider loss of potential energy is equal to gain of kinetic energy. Increase of Ke. So what is the loss of potential energy? This amount is the lost. So that is L mgl 1 minus cos theta equals half mv squared. Take it down. This is the second type. This is recommended for simple questions, right? You don't see the difference here, but when you get like other questions, you will see. Using this one saves time, right? Take it down. This is the second type. Those are the 2 types you have to consider. But this is for simple conversions. Okay, if you've taken it down, then try 8th question. 8. Draw the sketch first. So this is a smooth path, right? So it is obvious for a question like this, you cannot apply linear motion equations, right? Because the motion is not linear. So you must go for energy conversions. Okay, you must go for energy conversions. Right. So this is a smooth path, meaning this doesn't have friction. If it doesn't have friction, there's no energy loss. There's no mechanical energy loss. Okay. So the mechanical energy is conserved, meaning Ke plus Pe is a constant. That's what it means. Ke plus Pe is a constant, right? So here it just starts to slip. Velocity here is 0, right? So at this point it only has a, so the potential energy, sorry, kinetic energy 0, potential energy is what? mgh, mass is 2 kilogram. So 2 times 14, 28 times 10, 280 joules. Understood? mgh, right? 2 times 10 times h is 14. 14 times 2, 28 times 10, it is 280. So 0 plus 280, that's the total energy there. What's the total energy here? 7 meters means if you apply mgh, 2, 10, 7. 14 times 10, 140 joule. So 140 joule is the mgh, potential energy, plus kinetic energy. Understood? So energy, total energy is 280. Here the total energy is 140 plus kinetic energy. Energy here is equal to energy here. So there the energy is 280. Energy here is 140 plus kinetic energy. So you can simply put 140 to the other side and you can take 140 joules as the kinetic energy. So that's going to be the kinetic energy here. Understood? So we use type 1, right? TE1 equals TE2. State 1, state 2. These are the two cases. 1, 2. Energy here is equal to energy here. Take it down. Yeah, the answer should be first. Okay. So I solved that using type 1. Type 1, right? What is type 2? So you are thinking about energy conversions now, right? Here you have to consider loss of potential energy. So the object has moved from here to here. When it moves, what's the loss of potential energy? This has a, if it is 7 meters, there's a 7 meter drop here. That reduction of potential energy has to convert it into something, right? So that should be converted into kinetic energy here. So what's the loss? Loss of PE is equal to increase of KE. Okay. So loss of PE, that is mgh equals half mv squared. So mass is 2, 10, loss is 7. Half mass is 2 v squared. Sorry, what they ask is Ke, right? You don't have to find the velocity. So I'll just write Ke here. What do you get? 14 times 10, 140. Okay, 140 joules. This is the second type. So you get the same answer. You have to practice for both types, right? This type is going to save you some time, but you have to be careful when you are using second type. You got the answer because the energy here is kinetic energy here is 0. That's why you got the answer. But in other cases, always it is safe to use this method. Total energy at one state equals total energy at another state, given that there's no mechanical energy loss, right? Right. Then try 10th question. 10th question. If you find this hard, do these questions again, right? You have to think alone, right? Try by yourself these questions. You don't understand at once, right? So these are the basics. You must understand these, right? Without understanding this, there's no follow-up for the remaining part of the syllabus, right? So somehow you have to understand, right? Repetition is the key to understand this. Yeah, if you don't understand, right? Okay, try 10th question. If you got the answer, send me. Okay, let's say the mass of the car, simple m. So here you can write kinetic energy gained by the car. Final minus initial. Final kinetic energy is half mv squared. Initially it doesn't have kinetic energy, so we have equation E equals half mv squared. This is the energy gained by the car. It is provided by the engine, right? So the work done by the engine is converted into the kinetic energy of this car. So they are not saying anything about engine, right? They're just asking about kinetic energies. So you have a v increase of velocity. Velocity increases v. And the kinetic energy required for that is capital E. At the second stage, you have the same amount of increase, right? Here the velocity has increased by a v amount. But the kinetic energy increase is not going to be E. Let's calculate that. Let's calculate at the second part. Half m 2v squared, right? This is the kinetic energy here. Half m 2v squared. Minus kinetic energy here. Half m v squared. So this is 4v squared. You can take half m out. So 4v squared minus v squared. You get half m 3v squared times 3. So instead of half mv squared, you can use capital E. E times 3. What does it mean? Velocity increase is the same, but the kinetic energy required is 3 times at the second stage. Someone can think, since the velocity increase is the same, kinetic energy increase also is going to be same, but it is not, right? Kinetic energy increases 3 times. Yes, it is the third answer. Take it down. Try these questions again, right, to solidify your knowledge, right? Then try 11th question. Better draw a graph. Sorry, not a graph, I mean sketch. Right. You have a horizontal ladder. Mass is given as capital M and the length of the ladder is capital L. Length of the ladder is capital L. So what do? We make it vertical. The ladder is made vertical like this. So what they ask is work required for that. So if you need to vertical, that was horizontal ladder, you have to do some work, right? So what they ask is the work required, actually the minimum work required for that. So this is the another type of questions, right? What can we do? You have to think about the gravitational center of gravity. You know that center of gravity is for any object, not any object, I mean uniform object, at the middle. Initially the center of gravity is here. Let's say this is P equals 0 line. So what is the specialty about center of gravity? center of gravity represents the whole object. That's the very important point, right? Center of gravity of an object represents the whole object. Okay, so instead of this whole ladder, you can think the ladder as a point mass with capital M. So what has happened? That point mass, instead of the ladder, think about this point mass, capital M. The capital M is lifted by L over 2 amount. So what's the increase of potential energy of the system? M, capital M, G, lifted amount is L over 2. So this potential energy is the work we did. This is the increase of energy, right? So that increase was caused due to the work we did. So the work we did should be equal to this one, mgl over 2. Understood, right? Take it down. Draw this, right? Then take it down. Right. Then try 12th question. 12. Try that. So we have an object with mass m, and there's a resistive force acting on that, right? Let's say the resistive force is capital F. So due to this resistive force, what happens? The object stops here after moving a distance simple x. Object stops after moving a distance simple x. That's what happens, right? Now think about how the energy has conserved. If something has energy, it loses its energy, meaning it converts into a different types, right? What can we do? Like, there's this object. It has, they say, a momentum, right? But momentum means this has a velocity. This has a velocity v. I'll deal with the momentum later, right? So this has velocity v. Why does it stop here? This has kinetic energy. At this point, the system has lost all its kinetic energy. Why the kinetic energy becomes zero there? All that kinetic energy has consumed by this resistive force. This stops here because of resistive force, right? So in this case, energy conversion is something like this. This is the amount of kinetic energy it had, right, in the system. This kinetic energy is consumed by the resistive force. So that resistive force has done some work in order to consume all that kinetic energy. So it has completely consumed. So work done by this. So this is work done by F is equal to kinetic energy of the system. So that is what I have written. You should be able to write these ones, right? Work done by F, resistive force, is equal to the kinetic energy of the system. Okay, now the kinetic energy is half mv squared. What they ask is capital F, right? Since there's momentum, this is what you have to do. You just have to multiply both numerator and denominator by simple m. You can do that, right? Numerator and denominator by simple m. Okay. So mass cancels off. That is multiplying by 1. So if you multiply by, so this becomes m squared v squared divided by m. M squared v squared divided by m. So take square out. So mv squared. What is mv squared? P squared, right? P squared divided by m. This is fx. Then put x here. Cross multiply x to this side. So it becomes p squared divided by 2mx. So this is the resistive force in terms of momentum. Let me know if I have to explain again. If not, right. So the first thing you have to understand is kinetic energy of the system is consumed as work. This is a resistive force, right? So the resistive forces always consume the energy. This object has stopped here, meaning its kinetic energy is converted into something, or it is lost due to resistive force. So kinetic energy is completely conserved by the work done by the resistive force. So the work done by resistive force should be equal to the kinetic energy. Let's say this had like 10 joule of energy. This had like 10 joule of kinetic energy, right? Here. Let's say this is like friction. So friction is applying on that. So what happens? Due to this friction, object slows down, meaning kinetic energy is losing. Why is that? Due to friction. So friction is doing work against that its motion. So at here, completely this object stops, meaning the total kinetic energy of the object here has completely consumed by the resistive force. So that is kinetic energy is equals Fx. Up to that understood, right? Okay. So after that, they are asking about a momentum, right? After that, it is just a simple substitution. So you have to make this a momentum. You have to write this in terms of momentum. After this, the theory is over, right? What I need is over. After that, I had to convert this into a momentum. That's why I multiplied m and m like this. So this becomes m squared v squared divided by simple m. Okay. So mv is momentum. Then you can plug momentum there. Make it p squared divided by 2m equals fx. What they ask is resistive force. So you can cross multiply this and get the resistive force. You could have write it using these terms as well, but they asked the question resistive force in terms of momentum, right? That's why I needed to plug momentum here. Okay. The main thing you have to understand is this conversion. These are if you think about it, these are simple conversions, right? Something loses its kinetic energy. Why is that? Due to the work done by a resistive force. These are like some transfers, right? Energy transfers, so we can say energy conversions. Like that, you can write this. I'll do more questions on this. I'll be doing like this lesson 2 days, right? There are further questions here. I'll discuss that at the next class. Next class means on Thursday, next Thursday, right? On next Thursday, I'll be doing the remaining questions on this. And there is power and efficiency. There's another unit called power and not another unit, part of this power and efficiency. I'll discuss that at the next class, right? Just before that class, try these questions again. Because it is like very important, right? Very important. And if you have any issues with the problems here, you can send me and ask me how to do that, right? So once you get these ones, these are not very hard, right? But in order to gain the knowledge on that, you have to work hard towards that, right? Somehow you have to understand these, right? We'll meet you on the next class on Saturday to do this and the power and efficiency part. Then we can conclude the work and energy part, right? Right. Then good night. Good night, everyone.